we have this question. So the question is on surface development. So the figure shows a cylinder resting vertically on an equilateral triangular prism. So the prism has an equilateral triangle cross section. So we are supposed to complete the front elevation showing the curve of intersection and draw the development of the cylinder opened at AA. So the first thing is copying the views. So we have the views there. So we have copied the given views. Then we are going to draw the line of intersection. And there are stages which have to be followed. So remember, you have to draw the line of intersection before you do the surface development. So these were the given views. So we are going to draw a circle. So sometimes we use a circle or a semicircle. This part. So we'll use a semicircle. Then I divide it into 6 parts. So you can decide to use a circle, full circle, or a semicircle, as long as you be careful on numbering. So we start number 1, 2, 3, 4, 5, 6, 7. So remember, for a full circle, so after 7, we are going to 8, 9, 10, 11, and 12. So after numbering, we are going to drop vertical lines from those numbers. So if you are to draw the full circle, you realize that number 1 and 7 will be independent, but 2 will be paired with 12, 3 will be paired with 11, 4 will be paired with 10, 5 will be paired with 9, and 8 will be paired with 6. So if you draw a semicircle or a full circle, we are going to come at the same conclusion. So I'll project those points. So for number 12, it will be number 12 and 2. So up to, you can allow it to cut the triangle, this triangle shape, which is the prism. That way. So the same circle, we are going to draw it. I've not changed the dimensions, they're still the same. So we are going to draw the same circle in the front view or the front elevation. the same. Divide it into 6 parts. If it was a full circle, you have to divide it into 12 parts. Now we come to numbering. So this numbering is what is going to determine on how we are going to draw the line of intersection. If you number it wrongly, then chances are that you're not going to get the correct line of intersection. In this case, you're seeing number 1 and number 7 being independent. The others are being paired. So what is going to change is on number 4 and the pairing of, we have 4 and 10, then this 1 and 7. So in the end view, we are having here number 1 and 7. So 4 will be here, then 10 will be behind. It means on the other side. So if you come here in the front view, how we are going to see it is that number 4 and 10 will be at the extreme ends, then 1 and 7 will be in the middle, and they will be paired here. So this one goes back to how you view the end from the figure. Now in this case, this end has been viewed from this direction, and we are seeing that having 7 here and 1. So it means 1 and 7 will be at the center up above here. So we are going to place it here. Then 4 and 10 will be on this point. One of the will be on the extreme ends. Now, how are we going to place 4 and 10? Goes back also to the isometric projection or the isometric drawing. When you're having that isometric drawing, so how are you going, or according to the views? So direction of view also matters a lot. So I'm going to give this we're going to have here number 1. Now this point here, it's like we're turning it through an angle of 90 degrees. So view it as in isometric, where we are having a circle, and from here it has been turned through 90 degrees. For a complete circle, we have 360 degrees. So if it turns through 90 degrees, then it is going to be at this point. So it means it is supposed to be at the center here. So we'll be having point number 1, then we continue labeling, then number 2 will be here, 3, then we are having 4. So we go back, so we follow a complete circle. So from 4 you go to 5, 6, 7. So you realize that 7 and 1 will be on the same line, or in this case it will be paired. So 7, we go to 8, 9, then 10, it will be 11 and 12. So after labeling that, remember labeling was the most important detail in this drawing, since if you label it wrongly, you are not going to get the correct line of intersection. So again, we drop the perpendicular lines from the points. So that is for 9 and 11. We go to 8 and 6. 7 and 1 will be on the same center line which we had drawn. Then there is a 2 and 6. And then we have here 3 and 5. So let us now go to the plotting of these lines. So in plotting of this, let us now go to plotting of these points. So in plotting of the points, we'll still need to draw projection lines, which will be coming from the end elevation towards the front elevation. So I'll align one of the set squares. So I'll bring the other set square. So I'll use this other direction. Then slide it. So we are seeing that we're having 2 points that will be sharing the same line. So I've projected that horizontal line. Then last is from the apex of the equilateral triangle, which I had already drawn. So no need of drawing another line. So I'll extend these lines downwards so that all the lines are intersecting. So we start with number 1. So remember number 1 and number 7, they are sharing the same projection line. So we go towards this direction. So we are seeing for number 1 will be here. And they're still sharing the same. Then so 1 and 7, we have done with 1 and 7. Then there is 2 and 12. So 2 and 12 are sharing 2 and 12 are sharing with 8 and 6. And remember, there are points which are going to be visible in this side. The others will be behind. So having 2 and 12, then 8 and 6. So we're having 8 there. Then 2 and 6 is at that point. Then next is 3 and 11. Then we also have 5 and 9. They are sharing the same horizontal line. So we're having, if you look here, we're having 9 and 11. And there is also 3 and 5 on this side. Then the last one is 4 and 10. Then from the top, you can see that we are having 10 here, then 4 at that point. So after that, you join these using a smooth curve. And that will be your line of intersection. Then the next thing you are required to do was to draw the surface development of the cylinder along that cutting plane AA. So we start with that line. Then maybe we start doing it from that point. I'll measure 90 degrees so that I have a vertical line. That way. Then we are going to transfer the circumference of this cylinder to along this line. So I'll use a smaller pair of compass. Then take measurement of one division here. So the divisions are usually equal to each other. Then transfer it here. So remember, you have to transfer all of them. So that's the reason why we divided it, the circle or the semicircle which I've drawn there, into equal parts, so that it is easier for you to transfer the length instead of calculating the circumference. So according to the question, AA was along this line. You've been given that AA, that is a cutting plane. So the cutting plane along here, that will be at point 4. So it means we are starting to open that cylinder at point 4. So if you follow that sequence of numbering, from 4 you go to 5, 6, 7, 8, 9, 10, 11, 12, 1, 2, 3, 4. So we are starting at point 4, then we should end at point 4. After doing that, then you draw vertical lines from each of the points. And the vertical lines are easier drawn using set squares. You draw using set squares. After that, we are going now to transfer the heights. So we start with number 4, and number 4 is having the same height with number 10. So it means that if you are going to transfer that height, it is the same height as number 10. So take that measurement. So for number 4 there is also another number 4 here, then number 10. Next one is 5 and 3. We have 5 and 3, and remember also 5 and 3 is also sharing the same horizontal line with 9 and 11. So when you are transferring that height, so that is the height. So we'll do it for 5. There is also 3. That's for 5 and 3. Then there is 9 and 11. 9 is there. Then 11. Next one is 6 and 2. So 6 and 2 is also sharing with 8 and 12. There. So we have 6, 2, then 8, 12. Then last one is 7 and 1. So 7 and 1. So we'll take that height for 7 and 1. So there is 7 here. Then 1. So after that, we join that using a freehand. So try to ensure your curve to be as smooth as possible. Do it that way. Then remember, these lines were construction lines, the vertical lines. So I'll make lines to be bold on whatever is needed. That one should be bold. This one is also bold. And there you have your surface development. So we have answered the question. We have drawn the line of intersection and the surface development of the cylinder.